So, to find the inverse of any function back in algebra, your teacher would ask you to first switch the x and y and then solve for y. So back in algebra 2, if I gave you the function f of x equals 2x minus 3, first of all, everyone remembers f of x really just meant y, yes? Yeah. So your teacher would have you switch the x and y around. They'd trade places. And then you would solve for the y. So you would add the 3 over. And then you would divide everybody by a 2. So what we called, quiet down guys, whoops. That's supposed to be a big thing. I'm not, try again. So f to the negative 1, that means inverse, right? So the inverse function was 1/2 x plus 3/2. Now there is something that happened that was kind of interesting when you graphed a function and his inverse. They became reflections of each other over the line y equals x. So let's start with the original function, which I'm going to do in blue. 2x minus 3 starts at negative 3. And then your slope is up 2 over 1. Oh, geez. That's not good. Pretend. My inverse function starts at up 3 halves, which is up 1.5, by the way. So like, I don't know, right here maybe. And your slope goes up 1 right too. Now I did a really cruddy job of graphing this, but theoretically, if I did a good job of graphing this, you guys would notice that they were reflections of each other over the line y equals x, the line that has a slope of 1 and goes through the origin. Does yours look a little better than mine, hopefully? Darn. Okay. Well, pretend. Use your imagination. That's okay. So that's what should have happened. Shh. Okay. What? What?
Oh wait, did you start it? You started at 3.5?
Which is 1.5. Yes.
Is that little line thingy negative 3?
The for the blue line?
Yes.
Okay. Up 1 over 2. Up 1 over 2. For wait, which line?
For the red one.
The red one. Up 1 over 2. Yeah. Okay. So when an inverse is graphed, he should be the reflection of his inverse. The regular and the inverse should be reflections of each other over the line y equals x. Okay. There were a couple other things we need to know about inverses, and that's going to come up shortly, so just hang with me. But are you all comfortable with this notation? F to the negative 1 means inverse. So let's talk about what is the inverse of x squared minus 4. Graph both the functions and the inverse. So let's start by finding the inverse algebraically. So the first thing your teacher would have you do is switch your x and y around, and then your teacher would have you solve for y. Now what happens here, guys, when you square rooted? Oy.
Square root of x plus 4.
Yeah? Something else I'm thinking about, though. Remember your friend plus and minus?
Yeah.
Okay. Ignore the negative for a second. What does the square root of x plus 4 look like? Anyone know? No. If I could factor it, maybe, but I can't factor that. So what do square root graphs look like? They look like these guys. So, all right. So let's try this. If I graph the original guy in blue, I would have started at negative 4. What is x squared minus 4? What sort of a shape is that? You better know what a quadratic looks like. You guys are making a quadratic is a parabola.
Oh, so you just want to use it.
Yeah.
What does that look like? Is it elliptical or?
They're called parabolas. That's what I was looking for. Okay. Shh. Yeah, you can say U-shaped, but it's called a parabola. Yes. So you guys just told me that a square root of x plus 4 was like a side bend. But what does the plus 4 shift it? Right or left? Left 4 units. Very good. So, I should have graphed this a little better. Oh well. He's going to end up... Oh, jeepers. All right, 0, 4, 4, 0. Did I screw up something?
I hope not, because I'm writing it down.
Probably. I don't know. I feel confused for a second. That's all right. All right. Okay, roughly, guys, that's what square root of x plus 4 looks like. The negative version of him would be down like this. Okay? Shh, the rumbling is getting annoying. Knock it off. YouTube just heard me scold y'all. Okay, moving on. Okay, let's talk about inverse trig functions now, because we're not in college algebra, so we got to talk about the real functions for us, which are trig functions. So we have inverse trig functions for sine, cosine, and tangent. And they are either referred to as inverse sine, inverse cosine, or inverse tangent. The other name that we use in this book is arc sine. Okay, arc sine, arc cosine, and arc tangent. Now here's what's kind of annoying. The inverse trig functions are only defined on certain parts of the unit circle over certain domains. Let's just start by looking at sine first. I'm going to do sine in blue. Sine, the inverse, is only defined between negative pi over 2 and positive pi over 2. Where is negative pi over 2 on the unit circle? Travel negative right here. So he's defined from right here all the way up to positive pi over, 2. We'll talk about why that is in 1 second. Okay, let's talk about cosine next. I'm going to do cosine in red. Cosine, inverse cosine, I should say, arc cosine, is only defined between 0 and pi. So that would be from here to here. And then let's do tangent in green. Arc tangent is only defined between negative pi over 2 and pi. So the same places where arc sine was. That's really ugly. Now they want us to talk about why that is. And I think to figure out why that is, we need to look at a concept back in Algebra 2. How did you know if something graphed was a function or not? Just looking at its graph.
Repeating x values.
Okay, repeating x values, meaning you had to pass a special test.
Horizontal.
Vertical line test. Okay, if the graph, and the horizontal line test is something. It's if the original passes the horizontal, then the other guy is a function. The inverse is a function. But if your graph passes the vertical line test, then he is a function. Okay, I'm going to tell you why. If I can get to the next page. Yep. Do you need to go back? Is that what you said? Oh, okay. You know what? Does everyone have a book? Grab your book. Because they can draw it a lot better than I can. If you don't have a book, look at your neighbor. All right, we're going to pause this. So we just looked in our book at some examples of those graphs and why they're only defined on certain domains. Now, let's look at, I'm going to keep this unit circle up here. I wish I had this one colored, but I don't. Evaluating in radians without using a calculator. Whenever they say without using a calculator, they're really telling you to just go ahead and use your unit circle. So if you have your unit circle handy, please grab it. Otherwise, you got to squint and try to read mine. They want to know where the arc sine, what is the value of arc sine at 1/2? Meaning, where in the unit circle is your sine function going to come out to a 1/2? Now we have a bit of an issue. There are multiple places where the sine comes out to 1/2, but you got to think about restrictions. What quadrants is arc sine defined? What did we just say? Quadrants 1 and 4. Very good. So between these two quadrants, there's only one place where sine is 1/2. I think that's, yeah, okay. How about pi over 6? Sorry, kid. Okay, letter B. Arc cosine this time, and I want to know where it's negative square root of 3 over 2. First thing I need to remember, where is cosine defined? What quadrants? Okay, quadrants 1 and 2, right? So I'm only looking in quadrants 1 and 2. And a place where cosine is negative square root of 3 over 2 is right here. 5, 5, or 6 is the right answer. And then inverse tan, arctan at negative 1. Where is tangent defined? In quadrants 1 and 4. Quadrants 1 and 4. Now, where on the unit circle do you see tangent being a negative 1? Remembering that tangent is sine divided by cosine. Yeah, right here. Now, here's an issue, guys. You can't tell me the answer is 7 pi over 4. Because tangent is only defined between negative pi over 2, I'm going to call it theta, and pi over 2. So can you give me a different name for 7 pi over 4 so that it fits this restriction? Very nice, negative pi over 4. There you go. Nice job. Okay, well, that's what your parents had to do when they were in trig, and that's why they're so grumpy about this. But you guys all have calculators that do this. And you know what makes your calculator even cooler? He already knows about the restrictions on arcsine, arccosine, and arctangent. So if you just crank this stuff in the calculator, it's going to give you the right answer. Now, careful, this time they want it in degrees, so make sure your mode is in degrees, please. And arcsine, remember, just means inverse sine of 0.5075. And I think these come out, I mean, they're not beautiful, but they're okay. If you're in the wrong mode, it'll be really weird. I got 30.5 degrees because it says to the nearest tenth of a degree.
Are we gonna have to do it the other way too?
The only reason you'd have to use your unit circle is if I needed the answer in radians. Now, theoretically, you could use your calculator and then convert it to radians. You could be a little sly. Some people find it's quicker just to use their unit circle no matter what. Worst case scenario, your calculator died on you and you can't use it. Here's a little aside. Did everyone know that my calculator died on the first 5 minutes of my ACT test? My calculator died right away on my ACT test. Died. And actually, funny story, it didn't actually die. This was right when they first came out. We didn't know a lot about them. My pixels just dimmed to the point where it didn't show up on my screen. Like my batteries were dying. All I had to do was darken it. But no, I didn't know that, so I just took my whole test with no calculator. It was fun. I did great. You can do the whole test without a calculator. Okay, so arcsine, did you guys type in this one? Arcsine negative 0.5075. What'd you get? Same thing but negative. Okay. And remember, your calculator already knows the restriction, so you don't have to think twice about it. How about arccosine of 0.6428? 50. Is it exactly 50? Okay. Since it said to the 10th, I'm going to put a 0.0. Shh. And then arctan of negative 4.475. There you go. Nice job. All right, so now you see why your parents are grumpy. They didn't have this luxury when they were growing up, so they get a little ornery when you use your calculator. I understand. Okay. These are right up ACT alley. You see? Oh, they're programmed. They have, there's a, like when your parents used to do these problems, they didn't even have a unit circle on some things. They'd have to look up charts. And then they basically program the charts into the calculator. They're functions, so it's possible to program anything into a computer. Okay, so evaluating sine of arctan of 3/4 without using a calculator. Now we can do this. And actually, this is the only plausible reason I need you guys to even know what arcsine and arctan and arccosine are, because these are on the ACT. Now,
I'm gonna bomb this.
no, this is easy stuff once you realize what they're asking you to do. The first thing it says is, okay, the arctan of 3/4. Let's draw ourselves a little triangle. And I'm going to assume everything I do is in the first quadrant, even though I realize it might not be. So, draw yourself a little triangle. if you took the arctan and got 3/4, that means the tangent of this triangle is set up in a way where its ratio would be 3/4. So tan, opposite over adjacent. Can you guys do a little calculation and tell me how long? Actually, you don't even need to calculate. We know the hypotenuse is a 5. Now look what the question's actually asking you. What is the sine of this triangle?
Opposite over equation.
Yeah.
Hypotenuse.
Yeah, that's what you meant. The answer is 3/5. That's exactly how I want you to do that question.
That's pretty easy.
Yeah. What they do is they give you one clue to start you off drawing your triangle, and then you fill in the rest of the triangle, and then you know the other functions. So the next one, I gotta draw myself a little triangle again. Oh, I guess I didn't have to draw. It's the same triangle. Okay, so you guys told me the cosine of this guy is, I heard 4/5. Very nice. And then, oh my goodness, what do you think happens with sine applied to an arc sine? Yeah, they just completely cancel out. Your answer is 3/5. I do too.